Page number 31, entropy. So let's go through the lines of the books. Now we are going to introduce a new concept which is known as entropy, and which is a quantity of prime importance in the discussion of science. That means it has a great importance. Okay, to have energy in a system is not enough to get work from it. Okay, so it depends on the condition of the system of that time. The following example will explain the situation. Till now, actually, we have that impression that if I have the energy, I can do some work. I am able to do some work. But sometimes it might happen that I will have some work, I will possess some work, still I will not be able to convert that work into, I will not be able to convert that energy into work. Now, this disability of converting energy into work is known as entropy. Okay, this is an idea. Also, we will get to know that how to calculate it. So again, I will tell you that sometimes it will happen that I will have the energy, but I will not be able to perform any work using it. So the disability of doing any work, even though you have energy, is known as entropy of the system. So let us see the situation that they are trying to explain. Let two water-filled vessels constitute a system. Okay. One vessel contains 500 kg water at 90 degrees Celsius and the other vessel has 500 kg water at 10 degrees Celsius. That means both the vessel has same amount of water but at different temperature. One is at higher temperature, another one is lower temperature. Considering the water at 90 degrees Celsius as source, yes, we always consider the source, heat source, which one is at higher temperature, and the other vessel and the other water at 10 degrees Celsius as sink. We can start an engine. Okay, so we can get work. Come to the next page. We can get work from the system till the water of the both vessel attain the same temperature. Yes, until they attain the same temperature, what we can do, we can take the heat out from the hot water, convert into work, and leave the rest amount of heat to the sink. And this process can be repeated until the temperatures become equal, or I can say the thermal equilibrium is achieved. Now, if we mix the water of the two vessels, we will get 1000 kg water at 50 degrees Celsius temperature. So both the masses will be added together. Okay, 500 plus 500, 1000 kg. And about the temperature, what will happen? The 90 degrees Celsius water will be giving up heat, and the 10 degrees Celsius water will be receiving heat. And the temperature of the 10 degrees Celsius water will start rising. From 10 it will come 20, 30, 40, something like this. And the temperature of hot water, that is at that the water which is at 90 degrees Celsius, it will start decreasing the temperature. Okay, so the temperature will decrease from 90 to 80, 70, 60. And if you take the average of them, you will notice that the average becomes 50. So we can say that they both will come at 50 degrees Celsius temperature. But from this water, no engine can get any work since there is no difference of temperature. Yes, when thermal equilibrium is achieved, both the water got mixed with each other and it became at 50 degrees Celsius. Now there is no difference of temperature. So what will happen? No work can be attained from this system. The flow of heat ceases. Ceases means stops. According to the first law of thermodynamics, though the energy of water before and after mixing remains the same, yet it is unable to convert heat energy into mechanical energy since the system has attained the thermal equilibrium. This is very interesting. A little bit ago, before mixing, we were saying that if I use the water of high temperature as source and the water of lower temperature as sink, we can form a heat engine and we can do some certain amount of work. We said that, right? But as soon as I mixed it, I did not take any energy out of it, right? তো আগে যতটুকু এনার্জি ছিল, যেহেতু আমি এখানে কোনো বাড়তি এনার্জি আমি দেই নাই বা এনার্জি কোনো কিছু আমি বের করে নিই নাই, so the same amount of energy is still there. But after mixing, what we saw that even though there is energy, we are not being able to convert it into work. So this is the disability of a system, that even though it is having a certain amount of energy, but it is not being able to do any work or supply any work. So as a result, I can say that the visibility of this system of converting into work is entropy. Okay, you will see that is the next line. The disability of a system to convert energy is known as entropy. We know that due to the work done on a gas, when it is compressed, there is an increase of internal energy and temperature of gas. Yes, whenever you compress it, obviously the internal energy will decrease because the molecules will start vibrating at higher temperature, higher frequency now. Okay, there will be more and more collision. So as a result, the kinetic energy will increase and internal energy also will increase, and which will increase the temperature of the gas because more collision will result in increased amount of heat energy produced. Okay, the more collision, the more heat energy produced. We know this, right? Whenever we are having some collision, friction, heat energy is produced. So when more collision is there, heat energy will be produced, and as a result, temperature will rise. Acha. Again, when a gas is allowed to expand adiabatically, some work is done by the gas. Therefore, it is observed that in an adiabatic process, both the internal energy and the temperature changes. We know. Uh, Adiabatic process is the one where no heat will be supplied and no heat will be taken out. Okay, so temperature will change. The quantity remains constant in an adiabatic process like temperature in an isothermal process. Yes, this is what we already know, right? The heat energy remains same in adiabatic process just like the temperature remains same in isothermal process. Clausius named this quantity as entropy. Entropy is a physical quantity. Physical quantity means it can be measured. Okay, as I already gave you an example of quantity, like which are the things that I can refer to as quantity. The things that can be measured are called quantity. Like if I ask you that how much long is your hand is, so you will be able to measure it using a ruler, and you will be able to tell me that, sir, okay, it is 12 centimeters, 13 centimeters, something like that. You will be able to give me a numerical value. But if I ask you that, are you feeling sad? You will say that, yes, sir, I am sad today. Then I will ask you how much sad you are. Will you be able to tell me, sir, I am 5 kilometers sad, or I am 3 kg sad? Will you be able to give me an amount? No, you cannot give me any amount. That means the feeling, these things are such things that cannot be measured. It can only be felt, right? So these are not quantity according to physics. Okay? Acha. So entropy falls in the measurable quantity side. Okay, it can be measured. I can find the value of it. So we will see how we can calculate it. And entropy is represented by S. Okay. Now, definition: the disability of converting energy of a system or unavailability of energy to convert it to work is entropy. This is what we just studied. The disability of the system. Okay. Now, if you go through the explanation, it has not yet been possible to measure the absolute magnitude of the entropy. If anybody absorbs or rejects heat, then its entropy is changed. Yes. So, the change of entropy is measured by the rate of absorption or rejection. This line is very important. The change of entropy. So, we might not be able to measure the entropy, that what is the value of entropy here, but we can measure the change of entropy before and after the heat energy is supplied or taken out. We already got to know that whenever we are supplying some heat or we are withdrawing some heat, in short, we can say that whenever there is a heat exchange, what will happen? The entropy will change. Okay, that means the disability will change. Okay, sometimes the disability will go up and sometimes the disability will be lessened. So when I can actually measure the difference between the final disability and the initial disability. Okay, I can measure the distance between them, but I do not know what is the value of them. It is just like if I tell you that the price of the shirt has changed by 5 taka today. So I told you by what amount it has changed, but from here you cannot tell me what was the initial price and what was the final price. It might happen that the initial price was 13 and the final price is 18. The difference will be 5. Or it might be possible that it was 20 before, now it is 25. The difference is still 5. So from here, what I'm trying to explain is, I will be able to tell you the difference only, not the initial or the final value. Okay, I can just tell you the difference. So the difference is measured by the rate of absorption or rejection of heat by the system with respect to temperature. So if you take a look at the equation 1.53, you will notice that as it is with respect to temperature, we have divided it by temperature T, and we saw that in the numerator it is going to be the heat absorbed or heat rejected, and that is actually the amount of heat change, right? If I supply the heat will increase by the amount we have supplied, and if I take out the heat will be reduced by the amount of the heat taken out. Achha. So ds is equal to dq by t. So this is the equation for entropy. Okay. Now from equation 1.53, it is seen that since the working substance do not exchange heat with the surrounding in an adiabatic process, yes. Now it specifically in case of adiabatic process, what is going to happen? We are not supplying any kind of heat. So if we are not supplying any kind of heat, the entropy is never going to change, right or wrong? So this one we can prove mathematically also. See, dq is equal to 0. So if I replace the value of dq as 0 in equation 1.53, which is ds equal to dq by t, so dq replaced by 0, so ds equal to 0 by t. As a result, ds becomes 0. Now what is ds? The change in entropy. So the entropy change is 0, which means the entropy will not change. Okay, initial entropy and final entropy, they both are same. Achha. That is, in an adiabatic process, there is no change of entropy. This is very important, okay? In question B part, in creative ABCD, 4 parts are there. So in B number question, you might be asked that why in adiabatic process, the entropy remains same or unchanged, okay? Therefore, by entropy of a system, we mean a physical quantity which always remains constant in an adiabatic reversible process. Now, many times I have seen students writing this definition for entropy. I suggest to avoid this statement. You may write it as extra information or added information, but the main definition that you should be writing about entropy is the one that is written at the middle of the page, upper middle of the page. See, the disability of converting energy of a system. This is the main thing, main idea of entropy. Okay, so please, whenever you are asked to write the definition, write this one. And after that, if you have time and if you find it logical, then please add this information also, that for adiabatic process, adiabatic reversible process, it is going to be 0. Achha. Now, then we have a little bit of calculation. This calculation, okay, I have 4 minutes left, so I can show it within this amount of time. That means the calculation that is in page number 32. We are going to take a look at that. And in the next class, inshallah, we will start from change of entropy in reversible and irreversible processes. That is in page number 33. Okay? Achha. So let us see. We know that ds is equal to dq by t. Now, d is something we use for a small amount of change. Now, let us say I'm not dealing with a small amount of change. So, I can write del s is equal to del 2 divided by t. Okay. Now, if I integrate it, okay, let us say this line I want to integrate. So, ds is equal to dq by t. So, now if I integrate it, what will happen? I have to put the limit, upper limit and lower limit on the right hand side, right? Here integration and differentiation, they will cancel each other. It will just become the entropy. So here what is supposed to happen? What will happen here? The entire amount. This is for a small amount, and when we integrate it, the entire amount of entropy change will be here. Now before I replace the limit, let me replace the value of dq. What is dq? dq, if you remember, we studied ms dt, ms dt. So we will replace here ms dt. Now do not get confused in this s. This is not entropy. This is a specific heat, if you remember. So these m and s, they are constant, so they will come outside. And it will be dt by t. Now, as I have t with t, I will put the limit of t, that is from t1 to t2. Now, if you remember, there is a formula of integration 1 by x dx, which is equal to ln x. I explained this one a couple of days ago also. So from here, what I can write, ms will be there, and this will become ln t. Upper limit is t2, lower limit is t1. Now what I can do, I can replace the upper limit minus the lower limit. So if I do that, the equation is going to look like this: ln t2 minus ln t1. Now if you remember in grade 10 higher math, we studied this formula that if I have ln m by n, I can write it as ln m minus ln n. Right? So we will apply the same thing here. If as there is minus, so I can write it as divided. So what I can write here, ln t2 by t1. This is the expression we are looking for. Okay. So del S, that is the change in entropy, is equal to the mass into the specific heat and ln of the temperature of the sink and the temperature of the source. So if we know these quantities, then we can easily calculate the amount of entropy change. Okay. With that, Alhamdulillah, we have come to the end of our today's class. If you have any doubt, please ask before we end the class today. You have anything to ask?
No.
Okay.
Sir.
So kindly go through these pages and also try to take a look at the calculation that is in page number 33 and 24, so that you have a heads up before I explain it. Okay. Thank you very much. See you in the next class, inshallah. Assalamu alaikum wa rahmatullah wa barakatuh.